Hello! We are going to explore the composition of motions. We will study the composition of two rectilinear uniform motions in the same direction and sense, the composition of two rectilinear uniform motions with perpendicular directions, and finally, parabolic trajectory. All of this will be done taking into account the principle of Galilean independence, which tells us that when a body undergoes two simultaneous movements, its change of position is independent of whether the movements occur simultaneously or successively. Let's see, in this case, what happens to J. He is on a moving conveyor belt, and at the same time, he walks on it. Let's study what happens in this case. Well, let's consider first the movement of the conveyor belt. If the conveyor belt moves, the box moves along with it, but J remains at a constant distance from the conveyor belt. The conveyor belt moves due to the conveyor belt, which is the one with the motion, and we have referred to it as rectilinear and uniform motion 1. X sub 1 is therefore x sub 01 plus the velocity sub 1, which is that of the conveyor belt, times time. What happens now if it is J, the one moving? The box is still while J has moved away from it, having a position x sub 2 with respect to the box. Therefore, J performs rectilinear and uniform motion, called motion 2, and x sub 2 will be equal to x sub 02 plus v sub 2 times t. What happens now if both the conveyor belt and J move? If it moves, if the conveyor belt moves and J, the conveyor belt moves, but J moves much further. Therefore, the motion of J plus the conveyor belt will be the composition of two rectilinear and uniform motions that we've seen before, in the same direction and sense, and therefore the position of J will be x sub 1 plus x sub 2, as shown. That position will be an initial position, x sub 0, that will be the sum of the initial positions of each one of them, plus an initial velocity v sub 0, which is the sum of v sub 1 plus v sub 2 times time. Therefore, the result of the composition, it is a rectilinear and uniform motion. Therefore, the composition of two rectilinear uniform motions in the same direction and sense is a rectilinear uniform motion. It will have zero acceleration, it will have velocity. In direction and sense, in which these movements are performed, and therefore the position vector will be x sub 0 plus v sub 0t in the direction in which it is performed, which in this case was the x-axis, and we multiply it by y. Let's see now what happens if we have the composition of two rectilinear and uniform motions in perpendicular directions. For that, we will consider that J is rowing, but let's take into account the motion of the water. The water is going to perform a rectilinear and uniform motion in the direction of the x-axis. It is going to have a velocity v sub 0x along the x-axis. Then the position x will be equal to x sub 0 plus v sub 0x t, since the motion is rectilinear and uniform. Then r sub 1 will be x times y. If we now analyze the motion of J, which we have called motion 2, we will have that it is a rectilinear and uniform motion in the direction of the y-axis, since J rows in that direction with a velocity v sub 0y. Then the velocity of J will be v sub y equal to v sub 0y times vector J. Y will be equal to y sub 0 plus v sub 0y times the time, and therefore the position vector will be this one that we mark here. What happens if J paddles and at the same time the water is in motion? Well, we will have a composition of motions. The velocity will have x component and y component, since it is the sum of the velocities of each of the previous movements. Then the velocity is the vector sum of the velocities, and the position we will calculate from r sub 1, which was the position vector of the water plus r sub 2, which is the position vector of J, if they were the only ones performing the motion. Therefore, the composition of these two motions is a position vector that has an initial position vector with x and y components, since the motions are performed in perpendicular directions, and a vector v, which in this case also has x and y components. Therefore, the composition of two rectilinear and uniform motions in perpendicular directions is a rectilinear and uniform motion. The acceleration is 0. The velocity is the vector sum of the velocities of each of the motions, and therefore the position vector will be the vector sum of the initial position vectors of each of them, plus the vector sum of the initial velocity vectors of each of them times the time. Let's see now the parabolic trajectory. For that, we are going to take Jay in his basketball training sessions, and let's look at how he throws the ball. He throws the ball with an angle of inclination and with an initial velocity. Therefore, the parabolic trajectory is going to be a composition of two motions, a rectilinear and uniform motion on the x-axis, and therefore the equations governing this are the ones shown here. The velocity vector is a constant vector along the entire trajectory, and uniformly accelerated rectilinear motion along the y-axis. Therefore, the acceleration vector is constant and is always directed downward. Therefore, in a parabolic trajectory, we have an acceleration that with our choice of axis only has component on the y-axis, which is where the uniformly accelerated rectilinear motion takes place. The velocity is the vectorial sum of the velocity vectors of each of the motions that make up the final motion, the parabolic trajectory, and the position will also be the vector sum of the position in each of the axes. Let us now calculate the maximum height reached by the object. For that, the condition we must impose is that the y component of the velocity is 0. From that expression, we calculate the time and substitute the value we obtain in the expression of y, finally obtaining the maximum height. To calculate the maximum range, we take into account the position. The maximum range corresponds to the condition y equal to 0, since we will be at that point. We calculate from there the time, and we substitute in the expression of x, with which we will obtain what is the maximum range. Well, the time has come for Amanda to remind us what we have seen in this class. We have seen the composition of two uniform rectilinear motions with the same direction and sense, and we have obtained the expressions that characterize it. It is a rectilinear and uniform motion in the direction in which each of them take place, where the velocity will be the sum of the velocities of each of the independent motions. We have also seen the composition of two rectilinear and uniform motions with perpendicular directions. the result will also be a rectilinear and uniform motion. But in this case, we will have to add vectorially the velocities of each of them. And therefore, we'll have x component and y component. And we have also found the position in this case. And finally, we have seen the parabolic trajectory, which is the result of the composition of a rectilinear and uniform motion on a horizontal axis, which we have considered to be the x-axis, and a uniformly accelerated rectilinear motion on a vertical axis, which we have considered to be the y-axis. From here, we have obtained the expressions of the acceleration, velocity vector, and position vector. That's all. See you in the next class.